Hi everyone, today we are going to learn about completing the square and using our skills about completing the square to another level. So in our last lesson, we learned how to solve quadratic equations by completing the square, and in today's lesson, we are going to use the completing the square technique to go back and forth in between standard form to vertex form, and we're also going to have a couple application problems as well. But before we get started, I would like you to go ahead and pause the video and solve each of these equations not by completing the square, but instead I want you to factor each of these equations and solve for x. So remember, factoring is where you want the equation to equal 0, and then you want to break the trinomial apart into two parentheses if you can, and then set each parenthesis equal to 0. So go ahead and pause the video, and when you have an answer, go ahead and restart it. And we'll see how well you did. All right, so factoring, if you're asked to factor, then we want our equation to be equal to 0. So I'm going to start off by subtracting 6 on both sides, and I have x squared plus 5x minus 6 is equal to 0. I'm going to break this apart into two parentheses, still maintaining that this equation is equal to 0. A lot of times kids lose this equal 0, forgetting that they're solving an equation. So please make sure that you do not lose your equal 0 whenever you're solving an equation. I'm going to split apart the x squared into an x and an x and ask myself what two numbers multiply together to equal negative 6, but together add to equal positive 5, and that's going to be I'm thinking that it's going to be positive 6 and a negative 1. 6 times negative 1 is negative 6, and 6 plus negative 1 is 5. So I'm going to put in a plus 6 and a minus 1, and setting each parenthesis equal to 0, I find that x equals negative 6 or x equals positive 1. Please note that your skills for factoring is going to be something that we're going to be doing on every single test. So factoring will be on this next test, so please keep that in mind. For letter B, both of these terms have in common a 4, so I'm going to factor out a 4. And my leftovers is x squared minus 100 is equal to 0. Now, x squared minus 100 is what we call a dots, a difference of two squares. And a difference of two squares can be broken apart into two parentheses, where you split apart the x squared into an x and an x, and then you take the square root of your last number. The square root of 100 is a positive 10 and a negative 10. So your solutions are x equals negative 10 or x equals positive 10. Now, if you struggled on solving these equations by factoring, this is something that I need you to please make sure that you come and see me either after school or you email me about, or let me know whenever I'm walking around the class so that I can address your questions and concerns. Because like I said, factoring is not going away. It will be on every single test for the rest of the school year. So I need you to become very comfortable with this concept. Now, transitioning to completing the square. Today's objective is I want you to be able to say that you can rewrite quadratic functions written in standard form into vertex form using the completing the square skills. So I'm going to give you a function that's written in standard form, that's ax squared plus bx plus c, and I want you to turn it into vertex form, which is a times x minus h squared plus k. So that's one thing that we're going to be doing, and that's our first set of problems. Our second set of problems is going to be where I need you to be able to say, I can use completing the square to identify the maximum of a real-life model and the area of a triangle. So we're going to be working with the area of a triangle, and we're going to identify a value of x for that type of problem. So let's go ahead and recall what vertex form is. Vertex form is y equals a times x minus h squared plus k. That is vertex form. And notice that we have ourselves a parenthesis squared, which is what we were working with, that thing that we've been working with when we've been solving by completing the square. So this x minus h squared is something that we're going to be using. We're going to be changing somewhere in the middle of our process, we're going to end up with a perfect square trinomial that we factor down into a parentheses squared. It says to write a quadratic function in vertex form, we just complete the squared. What you want to do is you want to be sure that you isolate your y value for your final answer. So when you're absolutely finished, you want to make sure that your y value is alone at the very end. Well, what I'm about to show you is a little weird, so please make sure that you write down every single step that I show you. So when we're completing this, when we're trying to change this into vertex form by completing the square, we're going to rewrite our equation so that it has just an x squared plus bx on one side. So we want just an x squared plus bx on one side. So I'm going to bring this 22 to the other side, but be careful. You are going to leave space for a new c value. So I'm going to write this as y, and I'm going to subtract 22 on both sides. So I'm going to write y minus 22 plus, I'm going to leave space for a new c value, equals x squared minus 10x plus space for my new c value. The reason why I have my new c value on each side is because whatever you add to one side of an equation, you have to add to the other side. And the way that you find your new c, once again, is your b value cut in half and then squared. So it's half of b squared. My b value in this case is negative 10. So I'm going to write negative 10 cut in half and then squared. So that is going to be negative 5 squared, which is 25. So I'm going to add 25 to both sides. By doing that, we now have a perfect square trinomial on one side of our equation. And on the other side, we're simply going to combine our like terms. So negative 22 plus 25, that is equal to 3. So I have y plus 3 is equal to, and I'm going to write this as a parenthesis squared. Half of negative 10 is negative 5, so that's going to be x minus 5 squared. Now, we're not going to take the square root of anything because we're not solving an equation. We're simply rewriting our equation from standard form into vertex form. So what I'm going to do now is I'm going to get y alone by subtracting 3 on both sides. By doing that, we end up with y is equal to x minus 5 squared minus 3. So in this problem, we were asked to write the quadratic function into vertex form, which means that we're going to be completing the square. And then it asks you to identify the vertex. And what's cool is that since this is in vertex form, we can very quickly identify our vertex. And in this case, our vertex is going to be 5, negative 3. It's the opposite of what you see inside of the parentheses, comma, exactly what you see outside. And that is your answer. If you want to try example number 9 on your own, I strongly encourage you to do so. You can pause the video at this time, or you can keep going with example number 9 with me. Whatever you choose is fine. All right, here we go. So for this problem, I need to bring 95 to the other side. So I'm going to subtract 95 on each side. And I'm going to write y minus 95 plus space for my new c value equals x squared plus 18x plus space for my new c value. Now your new c value is going to be your b value, which is 18, cut in half and squared. So half of 18 is 9, and 9 squared is 81. So I'm going to add 81 to both sides. Whatever you do to one side, you do to the other. We have a perfect square trinomial on one side of our equation, and we're going to combine our like terms on the other side. So negative 95 plus 81, that is equal to 14. So I have y minus 14 is equal to a parenthesis squared. And what's going to go into the parenthesis squared is x, and then half of 18, which is 9, so x plus 9. We're not taking the square root since we're not solving an equation. We're simply rewriting this function into vertex form, so I'm going to add 14 to both sides. And by doing that, I end up with y is equal to x plus 9 squared plus 14. And our vertex in this case is going to be negative 9, 14. It's the opposite of what you see inside and exactly what you see on the outside, and that is it. Number 10 is a little bit trickier, so I'm going to put some stars around this because I want you to please be careful for this problem. We're going to do the exact same thing as we did before by subtracting 7 on both sides, but notice that this time our a value is not equal to 1. So we're going to have to do some adjustments. So I'm going to write y minus 7 plus space for my new c value is equal to 5x squared plus 10x plus space for my new c. But we know that whenever we've done completing the square, we've needed our a value to be positive. Or sorry, excuse me, we've needed our a value to be the value of 1. So what we're going to do on this side is I'm going to factor out my leading coefficient. So I'm going to factor out the number 5. So I'm going to write y minus 7 plus space for my new c value is going to be equal to 5 times x squared plus 2x plus space for my new c. Okay, so what I did here is I factored out or divided out a 5 from each of my two terms. So now my new b value is 2. So to get my new c value, it's going to be my b value cut in half and then squared. So half of 2 is 1 and 1 squared is 1. So I'm going to add 1 on this side, but this is where it gets tricky. You are not adding 1 to the other side because think about it. If we were to multiply 5 back in, we would have 5x squared plus 10x plus not 1, but we would have 5. So technically we multiplied a 5. 5 times 1 is 5. We technically added 5 to the other side. So once again, we did not add a 1 to each side. We're going to add the number 5 because technically, if we were to distribute 5 back into the parentheses, we would have actually added the number 5 to both sides. So please be careful. 5 is our a value, and it's going to stay on the outside of our parentheses. On the inside of this parenthesis is a perfect square trinomial. So what I have here is I'm going to combine my like terms, and I have y minus 2 is equal to 5 times, this is going to be a parenthesis squared, and I have, this is going to be x plus 1 because it's half of 2, and half of 2 is 1, and the square root of x squared is x. Now I'm going to add 2 to both sides, and my equation is y equals 5 times x plus 1 squared plus 2, where my vertex is located at -1, 2. If you have any questions about this example 10, please make sure that you ask it in class next time I see you, or feel free to email me because I know that this is kind of tricky, but there are going to be questions like this on your test as well as on your homework, so I want to make sure that you understand what was going on here. We have 2 more examples and then we are finished. Here is example number 11. In example number 11, it says the height, y, in feet of a ball that was thrown up in the air from the roof of a building after t seconds is given by y equals -16t squared plus 64t plus 50. We want to find the maximum height of that ball. So remember that whenever you see the words maximum or minimum, what we're looking for is the y part of the vertex. So what we're going to do is we're going to convert this equation into vertex form. And then from there, we'll be able to identify our vertex y very easily. So we're going to convert to vertex form. And by doing that, we'll be able to identify the y part of our vertex very quickly and very easily. So I'm going to write down my equation of y is equal to -16t squared plus 64t plus 50. And I need to get my -16t squared and 64t alone, so I'm going to subtract 50 on both sides. By doing that, I have y minus 50 is equal to -16t squared plus 64t. In this case, once again, my a value is not a positive 1. So what I'm going to do is I'm going to factor out a negative 16 from these two terms. So I'm going to divide each number by negative 16. So I'm going to write y minus 50 plus space for my new c value is equal to negative 16 times t squared, and then 64 divided by negative 16. That value is equal to negative 4. So I have myself in t squared minus 4t, and then I'm going to write plus space for my new c value. Okay, so my c value is going to be my b value, which is negative 4, cut in half and then squared. So half of negative 4 is negative 2, and negative 2 squared is 4. So I'm going to add 4 on the inside of my parentheses, but be careful. I am not going to add 4 to the other side. Instead, if I were to multiply negative 16 back in, I'm actually multiplying negative 16 times 4, which is equal to negative 64. So I'm actually adding negative 64 to the other side. How I got that number is I took my a value and I multiplied it by my new c. Now, t squared minus 4t plus 4 is a perfect square trinomial, and we can write that as a parenthesis squared. And I'm going to combine my like terms on the other side. So I have y minus, and then negative 50 plus negative 64 is negative 114. So I have y minus 114 is equal to negative 16 times the parenthesis squared. And what's going to go inside of the parenthesis is t minus 2. It's my b value cut in half, and half of negative 4 is negative 2. Now I'm going to add 114 to both sides, and I end up with y is equal to negative 16 times t minus 2 squared plus 114. So let's go back to what the question was asking us. It was asking us to find the maximum height of the ball. And the maximum height of our ball in feet is the y part of our vertex. So in this case, our vertex is the ordered pair to 114. So in this case, the height of the ball, or the max height of the ball, is 114 feet. So that's what I'm going to write. The max height of the ball is 114 feet. And that is your answer. We have one last example and then we are finished. This example says the area of a triangle shown is 144 square units. We want to figure out what is the value of x. So remember that the area of a triangle is 1/2 base times height. That is equal to your area. So we're going to be using that information to help us to identify the value of x. So I'm going to write 1/2 times my base, which is x plus 10, times my height, which is equal to 2x, so times 2x. This is going to be equal to 144. So what I'm going to do now is I'm going to multiply my terms, multiply everything in. So what I mean is I'm going to distribute 1/2 into my first parenthesis, and that's going to be 1/2 x plus half of 10, which is 5. And I'm going to multiply that by 2x, and that's going to be equal to 144. So 1/2 times 2x, so half of 2 is 1x squared, and then 2x times 5 is plus 10x, and this is equal to 144. What's cool about this problem is that it's already written in the structure that we need for completing the square. So I'm going to write x squared plus 10x plus space for my new c value is equal to 144 plus space for my new c value. So remember that your c value is equal to your b value, which is 10. In this case, cut in half and then squared. So that's 5 squared, and 5 squared is 25. So I'm going to add 25 to both sides. I now have a perfect square trinomial on this side of the equation, and that's going to be x plus 5 squared. So that's the square root of x plus half of 10, which is 5. And that is equal to 144 plus 25, which is 169. From here, I'm going to solve this equation by taking the square root of both sides and eliminating the square. and I end up with x plus 5 is equal to plus or minus 13, because the square root of 169 is 13. Now I'm going to set up two separate equations. My first equation is x plus 5 is equal to positive 13, and x plus 5 is equal to negative 13. I'm going to subtract 5 on both sides, and I find that x is equal to 8 is one answer. And subtracting 5 on the other side, I end up with x is equal to negative 18. Now in this case, if we were to plug negative 18 back into our original problem, it wouldn't make a lot of sense, because 2 times negative 18 would equal negative 36, and you can't have a height of negative 36. So in this case, negative 18 doesn't make any sense, and x equals 8 is our answer. So whenever you are given a problem that has context to it, is like a story problem, we always give our answer as in context or with words. So what does 8 mean? Well, it means that 8 is going to be like 8 units, and this is square units. So we would say that the value of x is 8 units. And that is our answer, as well as the end of this lesson. So if you have any questions over anything in this lesson, like I said before, please feel free to email me, talk to me while you're in class, or see me after school sometime. I'd love to make sure that you feel comfortable with this concept. Other than that, I hope you have a wonderful day, and I'll see you next time.